I'm Professor Yu Shi. I'm an associate professor here at the Department of Computer Science and Engineering. A capstone course is designed for the seniors for the major of computer engineering students. So basically the students will come and they will kind of integrate all the knowledge they have obtained in the past like 4 years, all the knowledge they have learned. They will put together, like they will stay in the teams and work on the project together. They will plan the project, they will kind of come up with their own ideas, put things together, and eventually achieve whatever design they have in mind. So that's kind of like the practice to integrate everything they have learned in the past. So the capstone course is important because for the students, in their first few years of study, all the courses are kind of separate. So in each class, they will just learn the knowledge that are kind of related to the particular subject or the course, but they don't have an overview of everything. So we'd like to provide the students with an opportunity so that they can, put everything they have learned together in the kind of together. And then they can, have a project through the team collaborative work, so that everything, they can have the kind of experience through the designing the idea, the project idea, developing it, and then finally, trying to overcome any problems or challenges they expect or haven't expected, and eventually, they were able to achieve the goal. So it's kind of like the experience they will eventually have. That they will eventually be expected to have when they get into the career, but that's kind of like a preview of what they should be expected to see in their future career.
I'm Celeste Castillo.
Hi, I'm Michael Homer.
I'm Michael Hutchison.
I'm James Ryan.
For our senior design project, we have created Master Finder, an interactive tour guide system that allows Notre Dame students to take a tour of the campus at their own leisure. For inspiration of this project, we were inspired by Provnom Mysteries' Sixth Sense project, and from that moment on, we knew we wanted to create something that implemented computer engineering technology into the real world. So, without further ado, here's Master Finder.
So basically what's going to happen here is we've got a neural network on this Raspberry Pi with a screen, and what we can do is with this camera here we can take a photo of some of the largest buildings on campus, the big points. It'll bring up a preview, and then it'll take a photo, and in about 10 seconds it should hopefully come up with the right response. This should be the Hesburgh Library, and it'll play an associated audio recording with it.
With Jesus depicted in a famous mural as the Word of Life, facing Notre Dame Stadium as the great teacher, the 14 stories of the Hesburgh Library make an impact on football fans and on scholars from around the world. The image, best known as Touchdown Jesus, can be seen over the north end zone. It is 132 feet high and 65 feet wide, containing 81 types of stone from 16 countries. This building, which was the largest college library in the world when it opened in 1963, now joins with several other libraries on campus, collectively called the Hesburgh Libraries, to contain 3 million volumes, 2 million microfiche units, more than 17,000 serial subscriptions, and 12,000 audio recordings. The building is also traditionally an important gathering place for students on campus, whether they want to collaborate in groups, embark on a pursuit of study materials, or make use of the latest technology in their entrepreneurial research.
So the concept behind a lot of this is machine learning. So we use neural network to, you can use neural networks that kind of, they behave like the human brain to pick out patterns. So what this one does is it uses a image recognition neural network. The real challenge here was it's not just a software package, you also have to get it on the hardware. And the Raspberry Pi is very small and compact, which is nice for transporting it around, but neural networks require a lot of resources, so getting it onto the Raspberry Pi was a bit of a challenge, and Celeste can talk a little bit about how we did that.
Right, so we took TensorFlow on our computers. We trained TensorFlow with our 8,000 or so pictures of all the different buildings on campus, and then that produced an output file, 2 output files actually. One was a text file full of labels for each of the pictures, and the other was a retrained TensorFlow label graph. So the final graph is what we outputted to the Raspberry Pi, which is what's able to distinguish between each of the buildings.
This allows us to be able to distinguish a building like Hesburgh from a
Stonehenge.
completely different structure.
While we also understand the importance of the network as well as the training to get accurate images, it's also important to make sure that the GUI itself is going to be visually appealing to the user, as well as its importance of functionality. So one of the things we did was we tried to make it look all nice with like a nice Notre Dame banner, as well as large and easy to use buttons. So we have both a camera button as well as a power button to turn off the application. So you can easily hold it up to a building and then just press the camera button, and then the preview image will pop up, and then you can easily see what you're taking a picture of before it'll classify it.
As our final project at the University of Notre Dame, we really wanted to create something that could be used by future students, prospective students, current students, and the like, in order to give back to the university and I guess to showcase what we've done in our 4 years here. And I really think that we've accomplished that with Master Finder.
The first thing would be, the integration of the knowledge, like from whatever things they have learned before, they will be able to put them together. Now, in addition to that, they will also learn to, to kind of collaboratively work for those kind of complicated projects. They would learn how to do like teamwork, and also they will learn how to communicate with each other, in case they want to have some discussion about the project progress. They want to talk about the problems they had during the project. And in addition to that, they will also develop the capability to kind of solve or address challenges that emerge during the project development. So anything they did not expect at the beginning of the project, they should have a solution, so that they can eventually they should be able to finish it on time. And finally, I think one more thing that the students will be able to learn from this class is the capability to develop a comprehensive project proposal that can attract, for example, like future, funding sources. They want to have this commercialized. So we require each team to develop their own proposal, so that and then they will have also a peer assessment for all the proposals, so they can have those kind of. They also have a process to learn how to write, good and also attractive proposals. So these are the things we hope the students can learn from this course.
Hi, I'm Jack Klamer. I'm from Clayton, Missouri. So our project was a football robot that was designed to be autonomous so that we could use it to play robot football. We wanted to use a combination of both computer vision and radar, LiDAR sensing that we could then use to combine and create intelligent driving decisions, much in the way a Tesla does, but a much smaller and less grand scale. The team kind of divided into two groups of two. We had both Aaron and Ryan working very hard on gutting and re-implementing and rewiring all of the internals of the robot, and that included things like the Raspberry Pi, the Arduino, the Bluetooth shield on the Arduino, the cameras, the power banks, the battery, and then the LiDAR. And so getting all that into the robot in a compact way where it was locked down, so even when the robot was tackled, it all wouldn't go flying. So the physical challenge of the physical hardware was one thing, and then me and Andrew both worked on the computer vision solutions and kind of whittling down all the different ways that you could use computer vision. We started with very simple methods by which to try to do it, and then the other things that we could have done would have involved using a GPU. So he and I both worked on the software and also integrating the Arduino and the Raspberry Pi and getting two completely different computer systems that talk to each other.
I'm Andrew Libera from Grosse Pointe Woods, Michigan. We had a lot of challenges in this project. So the initial goal was to have a 100% fully autonomous robot for the robot football team. And this robot would be able to run plays and then avoid robots in its path and continue along with the route. Also, we would think we were thinking about having another camera that would be able to look for a ball thrown to it in the air, and so it would be able to center itself and catch the ball easier. But we ran into a lot of problems with hardware, specifically with the cameras, with the frame rate, and also being able to separate images we were looking to track from the background. Another issue that we came across was with the LiDAR that we were planning on using for distance, for object detection, like distance-wise around it, because the LiDAR can detect things that it kind of is like a 360 scan of what's around our robot. And that ended up not working correctly either pretty late in the project. So what we ended up doing was use one camera in the very front of the robot, and we came up with a system of LEDs to blast light right onto objects directly in front of us. So this allowed us to bring objects in the foreground of the image being captured by the camera into focus and really detect things that are about 2 feet away from us. So then we put some functionality into the robot so that it could juke to avoid these objects that are directly in front of us.
So in the first few weeks of the class, we do like lectures. So the lectures kind of serve as a, like point out the direction, like where they should go and, where they should be looking at the potential project ideas. But they have like very big freedom where they can, about the project ideas. So I ask the students to come and talk with me before they really kind of finalize their idea. So we can make sure that the project is not too complicated that they won't be able to complete in a semester, and also won't be too simple that they can just get it done in a week. So we kind of help the students to add or remove some of the content, when shaping the project idea. But pretty much the students have their own kind of entire freedom to decide the idea, what they want to work on.
Hi, I'm Dan Finnegan, and I'm from Long Island, New York. Yep, so for our project, we want to create a little robot that would deliver coffee to you in a classroom in DeBarlo. So the main idea was like, students, we basically run on caffeine. I know personally I can't survive it, and the struggle is that like there's the little ABP card in DBART, which is great, but if you're in class, you need to pick me up, you don't want to miss notes, or you're running late, as I often did, you can't get access to the coffee. So we thought that we would have two sides of a project. One was a software side, Android app, where you could pull it up on your phone and order a coffee and just enter what classroom you're in. And then it'd send a message to the people working at the coffee cart. They could get it, see it, brew it for you, put it in the robot, and send it on its way. And then it would, within a couple minutes, it'd be outside your door, it'd let you know, it'd send you a message, you could get it, get your coffee, and be back in class, rejuvenated, ready to go, and not missing a thing.
I'm Nick Pellegrino from Roselle, Illinois. Pretty much for our project, we had two distinct units between working on the robot and working on the mobile app to control it. So we had 2 of our 4 team members work pretty much exclusively on the robot, and then the other 2 worked exclusively on the mobile app. So I worked on the mobile app along with Jorge, and then Pollo and Dan worked on the robot exclusively. So for most of the semester, it was just our two-person groups kind of working independently, and then the last few weeks, once we needed to bridge the gap between the robot and the app, then we started working more together on making sure the whole demo worked cleanly.
So basically, in the peer review process, the students will read all the proposals submitted by all the teams. They will give a ranking to each proposal, like whether it's number 1, number 2, and how they like it. They will also need to provide specific feedback, like what aspect they like most about the proposal, what aspect they don't like. And also, we will provide these feedback directly to the students, so they can know from what others think about their proposal. Sometimes it's different from what they think, like when they may like a project idea a lot, but sometimes other people think it's not practical. They'll think there might be some challenges that will prevent them from eventually completing the project. So some things that they will not see themselves, but other people can help to see by reading the proposal. So, and also they will also learn, by reading others' proposals, they will also learn some additional techniques or tricks they can use to kind of make the proposal more interesting, like how to use the charts, how to use additional figures, how to, put things into like tables, organize the data. So all things they can learn from reading other proposals that will also help them eventually.